So 9.5, momentum. Momentum. Have you heard this term before, right? The momentum. Momentum is basically m times v. It is the mass times the velocity of an object. So it's an object that is traveling at a certain speed or velocity, certain velocity, and you multiply the mass and the velocity together. So if you have a large momentum, you can either have a large mass, object with a lot of mass moving at a certain speed, or you can have a small mass that is traveling at a faster speed or faster velocity, right? Okay. So that's basically what momentum is. Momentum is the problem with momentum. It is misunderstood with kinetic energy. Does anybody know what the equation for kinetic energy is? Has anybody heard the term kinetic energy?
Yes.
Okay, so kinetic energy is, there are two types of energies that an object has usually. Okay, it's going to be kinetic energy and potential energy. Okay, so we're just talking about kinetic energy. Kinetic energy is measured in this form. Okay, the thing about kinetic energy is not a vector. It does not have a direction component to it. Okay, so the velocity here is not velocity. You're looking at speed here, whereas momentum actually has a direction, okay? In other words, this guy here has a direction. You're just merely multiplying that directional thing by a constant of the mass, okay? So you want to make sure that you distinguish between these two, okay? All right, and the reason why it's kind of confusing is because it has the same mass, same that has mass, okay? Has a velocity, this is speed, but it's squared. So in other words, you know, an object that has a greater velocity is obviously going to have a greater kinetic energy. So they're kind of tied together, all right? Okay. So do not confuse momentum with kinetic energy, all right? Okay, so let's go to page 278. There is the mass, okay, momentum is a physical variable that is defined as a product of the mass and velocity. As you can see, there are little arrows there indicating this guy here is a vector, okay? All right. And then let's go to example 9.2. Determine the linear momentum of a person whose mass is 80 kilograms who is running at a rate of 3 meters per second. Well, that's pretty easy, right? 80 kilograms, right? That's the mass times 3 meters per second. Is it 3 meters per second? Yes. So it's going to be nothing more than 240 kilogram meters per second. Okay, all right. And then the second case is compared to the momentum of a car that has 2,000 kilograms. So I have 2,000 kilograms that is traveling at 30 meters per second. I'm going to get 6 with 1, 2, 3, 4 zeros, kilogram meter per second. Okay, huge difference there, right? 240 versus 60,000. Okay. Okay, and actually, bottom of 279, there's a little blurb that says kinetic energy is another quantity that is mass dependent and is used in engineering analysis and design. Okay, and it gives you the 1/2 mv squared. Okay, in chapter 13, you will explain the concept of kinetic energy in more detail. Okay, all right. Just a hint of things to come. Okay. So that was 9.5.